let's understand the postulates of kinetic theory of gases. To understand that, let us consider a three-dimensional box. We are considering a three-dimensional box which is filled with gas molecules. This three-dimensional box is filled with the gas molecules. Okay, so this is a gas filled gas filled 3D box. Gas filled 3D box. So the first postulate or first consideration of the kinetic theory of gases is that gases consists of gases consists of minute minute discrete particles called atoms or molecules. So this is the first postulate of kinetic theory of gases. That is, the gases consist of minute. Minute means tiny. Okay, tiny, very small, discrete particles, individual particles called atoms or molecules. So the gas molecules are considered to be small or minute atoms or molecules. This is the first postulate. Similarly, the second postulate says that the gas molecules the gas molecules the gas molecules in are in random motion in in all possible in all possible direction with different velocity with different velocity. So this is the second postulate of the kinetic theory of gas. That is, the gas molecules are in random motion in all possible direction with the different velocities. So if we consider a gas molecule like this, so what are the possible direction of its motion? So it will have total of 6 direction. That is positive x-axis, negative x-axis, positive y-axis, negative y-axis, positive z-axis, and negative z-axis. These are the 6 different directions in which a gas molecule can travel, and they are in random motion. Okay, they do not have any fixed motion. This is the second postulate. Similarly, the third postulate says that the molecules that is the gas molecules are constantly colliding among themselves and with the walls of the container. So this is the third postulate, that is, the molecules are constantly colliding among themselves. So molecules are moving randomly in all possible direction like this, right? So another molecule will be over here, and if one molecule is constantly traveling or moving in different direction, it will definitely to collide with other molecule, and those molecules may collide with other as well. And the molecules are not only colliding with themselves, they are also colliding with the wall of the container. Okay, so the molecules are colliding among themselves and with the walls of the container. This is the third postulate. Now let's see what is the fourth postulate. The collisions of the molecules the collision of the molecules with themselves and with the wall of the container is perfectly elastic. So this is the fourth postulate. That means the collisions are perfectly elastic. Perfectly elastic means there won't be any loss in energy or momentum with the collision. Okay. So if a molecule is over here, another molecule is traveling near it, and if it collides with this molecule, then there won't be any loss or gain of any energy. That is, the collision is perfectly elastic. So these are the four postulates. Now let's see the fifth postulate. The fifth postulate says that the molecules the molecules does not exert any force on one another. Any force on one another. They move independently. Independently. So this postulate says that there won't be any force of attraction, or repulsion between these two molecules. Okay, so all the molecules are moving independently. There is no force of attraction. There is no force of attraction or repulsion between them. Similarly, the sixth one is the volume occupied by one gas molecule. The volume occupied by one gas molecule is negligible in comparison to the whole gas. Okay, so the sixth postulate says that the volume occupied by one gas molecule is negligible in comparison to the whole gas. Now the last postulate is the kinetic gas equation. The kinetic gas equation of the gas molecule the kinetic gas equation of the gas molecule is directly proportional to its absolute temperature. So the kinetic gas equation of the gas molecule is directly proportional to its absolute temperature. So this is the seventh postulate.